who manages to trickle in as we get started. I imagine most of you found us through the Meetup site, but definitely be aware of that and look for updates there. So this is our August meeting, and this is our July meeting. No, wait,
August.
It's August. All right. I don't know what's going on. What's going on? This is our August meeting.
The late July meeting.
It's our late July meeting, no. This is our August meeting. Our September meeting is scheduled and is on the website, and we're going to have an introduction to Bayesian analysis in September, which I'm excited about. I think it should be good. So Greg Snow. Too many Marks. Too many Marks in the world. No, Marks are great. Greg Snow, who is a statistician at IHC, will be presenting about how to approach Bayesian analysis and what it is, and using R to do that. So that's what's going to be happening in September. So that is that. I think I'm thinking at the beginning at these meetings we might start doing just very brief, giving some opportunities for people to, if they're in an organization that's hiring, to maybe like briefly stand up and say who they are, like very briefly, like 3 sentences. I am so and so from X. We do Y, and we're hiring Z. At the beginning of the sessions, like give a little more opportunity for some networking, so people can know who is who, and to be able to introduce each other and whatnot. So we are a small group here, right, as of right now. So, but if anybody wanted to give that little spiel, I wanted to open up the floor. If anybody wanted to say hello. All right, excellent. How are we doing? Are we good? We're good, excellent. So, so I think many of you may know, but my name is Julia Silly. I am one of the organizers here, along with Andrew. And Andrew is your title statistician, data person?
Statistician works.
Statistician up at the U and the VA. I'm a data scientist at Stack Overflow. And our speaker today is James. And James, you are an engineer, a software engineer.
Solutions engineer.
Solutions engineer at RStudio, working remotely here in Utah. And we're very lucky to have him. And I'm actually really excited about this talk because this is a topic that I have dabbled in and doing the beginnings of, and have struggled some, had some success. And so I'm really excited to learn more about building these kinds of APIs using R and the ways that they can be used. So I'm really excited to learn more about it. So thank you, James.
Yeah.
Let's do this.
Great. All right. Very cool. So as Julie said, let me get my mic situated here. Okay. So yeah, my name's James. I've been working for RStudio as a solutions engineer for just a couple months now. It's awesome. It's the greatest thing ever. And I focus on integrating our professional products with companies and specifically their IT infrastructure. So I spend a lot of time on the phone with IT individuals. And then a lot of my job is as well creating like helpful resources, both internally, so for our support staff, as we see common questions, we'll write articles to support those. And then also externally, I write blog posts for our views. I do different things like these meetups and create resources that we use in demonstrations with customers and things like that. So it's a lot of fun. I get to work with a lot of brilliant people, and I get to work with a lot of cool tools that RStudio is developing, and it's, like I said, it's a lot of fun. So today our topic is building REST APIs in R, and I want to approach this from a very R-centric point of view because I think, at least from my experience kind of coming into this topic, I was kind of like, APIs, I don't really know what that means. And so I kind of shied away from it for a while, and it just seemed like this overly complicated deal. And Plumber's been out for a while now. It started to gain a little bit more traction, and I've started to find and embrace kind of the power of it. And so I hope that over the course of our discussion today, we get to a point where we recognize where this fits kind of in the R paradigm and why this is, in my opinion, such a big deal, especially when it comes to integrating R with other resources and systems. So just as an overview, we're going to talk just kind of as a general introduction of what API, like what an API is, and more specifically what a web API and what a RESTful API is. Now, as a caveat, I'm not like an API expert, but I do feel like I have a much better understanding than I did years ago. And I've actually been surprised with kind of the simplicity behind this. I feel like it's kind of, again, in my mind, it was this overly complicated deal. But now that I've kind of gotten into it, I hope that we can kind of view it through kind of a simpler lens. And then we'll talk about why we care. Why is this even important that I can make APIs in R? And then we'll dive into what Plumber is, how it works. We'll look at a couple of examples. And then if we've got time, hopefully we'll be able to look at some various ways of deploying Plumber. And then we'll close with some additional resources if you want to learn more. So what is an API? It stands for Application Programming Interface, which means nothing to me. But the idea is, really, it's a set of, not necessarily regulations, but a set of guidelines for dealing with some sort of program. And so we'll talk about web APIs today, and I'll get into what that means in just a second. But in general, I think most of us are probably familiar with APIs, even if it's not by name. For example, if you, assuming that we're all R users, if you use the tidyverse has a very opinionated API on how you interact with data, right? And so the pipe and the way in which the functions operate, there's kind of this set of guidelines around those to make them fit the tidyverse paradigm. And that could be considered an application programming interface, a way of dealing with and interacting so that there's kind of this commonality that exists across all interfaces. When it comes to the web APIs communicate through this protocol called HTTP. And HTTP is actually a fairly straightforward paradigm to understand. Essentially, it's just a specially formatted data bundle that's being sent back and forth. And one way to kind of think about this is, it's called the client-server architecture. So if you can imagine, and a good way to think about this is as like a phone conversation. If I'm going to call my mom and talk to her, I'll pick up my phone, I'll dial my mom, and I know who I'm contacting. She has caller ID, so she knows that it's me. It comes up with my picture and stuff. But if she didn't, she still gets the request, and she can answer the phone, and then we can have a conversation. And it's this two-way communication. HTTP is this way and means in which kind of everything over the internet communicates and interfaces with one another. And a client, so imaged here with this little laptop icon, makes a request to a server, which will accept that incoming request, determine if it's valid, do whatever the request is asking for, and return some result back to the client that the client then interprets. And maybe this communication happens, there's several instances of this back and forth. Maybe it's a one-time deal, a result's delivered, and that's the end of that communication. But the idea is HTTP is just the way in which this communication is handled. It's the set of guidelines that describes what this communication looks like, so it's consistent across all these different types of architectures that you may be dealing with, or with these different machines. So if I'm going to make a request in one area, and then I want to move over to another server, I don't have to relearn how to communicate with that server. The communication protocol and language is universal. We'll talk just briefly about what REST is. And there's a lot of research, and you can read a lot about what the idea of REST is. But essentially, this is just a kind of a further specification of how web interfaces should interact with one another, with an emphasis on performance and scalability. Those emphases are achieved by maintaining what's referred to as a stateless API. And the idea is that the server shouldn't contain any information about the state of the client. And again, there's a lot that you can read about that, but in essence, it means that everything that's important for the server to know about what this request is should be contained in the request itself, so that it's really easy for me to scale this out horizontally with additional servers to meet demand, and I don't have to worry about making sure that I also have access to who's who on the client side. Everything on the client side stays on the client side and is communicated as needed to the server. And it makes it really easy. The idea is you've decoupled the responsibilities of the client and the server, and it makes it really easy to scale your applications. It makes things more performant. Just makes things kind of easier to work with as data continues to grow and these systems continue to grow. So what does HTTP look like? And here's an example. So curl is a command line utility. Again, there's a lot that you can read about it, but essentially this is a way that you can make an API request from your own terminal, your own computer. And if you set this V flag, that prints out this verbose output that kind of gives you an idea of what's being sent back and forth. And this was kind of the turning point for me when I was like, oh, like that's all that's happening. Like it's not as complicated as for some reason I was led to believe. But essentially, this is the message that's being sent to the server, and then this is what's coming back to my client, along with this information down here. So if we break this down a little bit, this first line right here that starts with get, that's kind of the request line. So essentially what I'm saying is I want to get something from the server. And there's various verbs that you can use in HTTP. Get is very common. In fact, your web browser will use get. Whenever you visit a website, it sends a get request and says, hey, give me all the information about this website. The server responds, and your browser will render that into a web page. So get, and then here's the protocol that I'm using. Everything nowadays is mostly using HTTP 1.1. And then this /get is the specific endpoint on that server that I want to perform this request on. The host is the address of the server that I'm making this request to. And so the full, if I were to build like a URL out of this, it would be this host plus this particular endpoint, right? Is where I'm sending this particular request. And then there's some additional information. These are called headers. In HTTP 1.1, host is a required header. You have to have that in there. Everything else is pretty much optional, but it's nice to include some additional information. This is who's making the request. You could edit this and say, hey, this is James, I'm making this request. But most utilities will have something that identifies, hey, this came from, in this case, curl. This came from Postman. This came from something else, right? And then here's what's coming back. First is this first line that says, hey, I got your request. I'm communicating over the same protocol. This is the HTTP status code. So if you've ever reached a web page that's like 404 error, right, or you've seen these error pages, that's a result of this transaction happening. And this returns some sort of numerical error that then the website interprets and says, hey, you did something you weren't allowed to do, or something went wrong on the server, right? And there's several different distinctions of errors, and you can read a lot about those. And then this OK description is kind of the English interpretation of this number. So in this case, 200 means everything was a success. I understood your request. I'm coming back to you. And then all this is just additional information. Here's what I'm transmitting back to you. It's JSON. Here's how many bytes that JSON file is. And then just some additional headers that have been set by this particular server that we hit. And the last thing that we have is the data that's coming back to us. So this is the response body. All this is a JSON object that contains just the information that came from this particular server. Again, so from I guess kind of zooming back a little bit, all that's really happening here is I'm sending some specially formatted text to a server. It's saying, hey, I understood what you said. It's sending some more text back to me. And if I ask for it, it's going to include some data that I can then do something with. The nice thing is, again, this is a well-defined protocol that's really easy to work with and transfers across various servers and architectures. Now, this is all like really cool, but I'm an R user, right? So big whoop-de-da, like why do I really even care about this? And the answer is kind of interesting, I think. Here's why I care about it. And you decide why you care about it. But why I care about it is because when we think about what we do as analysts, statisticians, data scientists, whatever the case is, we do a lot of work. Like it takes a lot of work to analyze something. It takes a lot of work to derive meaningful insight out of a bunch of data, especially when that data is messy, especially when that data comes from questionable sources, right? We spend a lot of time hunkered over our laptops typing code that hopefully is useful to somebody somewhere, right? And so this comes from Hadley Wickham's R for Data Science book, but this kind of encapsulates that data science process, right? Here's what I do with my data. I bring it in, I tidy it, and then I spend like an incredible amount of time and effort in this little cycle here where I'm just iterating and trying to find I'm trying to find truth in my data so that I can transform whatever the case, whatever this business use case is, or derive insight or communicate something, right? And once I've finished this process or I've reached a state that I'm happy with the results, now it comes time to communicate. And this is where things kind of break down sometimes, at least in my experience, where, okay, I've done all this work and I have a one-page PDF, right? Or I've done all this work and I have an email and that's the end, right? And sometimes it can be a little bit disheartening to recognize that, well, there's this short shelf life on what I've done just because there's not really a good way to send this out there. Now, there's some ways around that. If in the R universe, if you use Shiny, you can build a web application that leverages all of the work that you've just done in R, or you can create an R Markdown report that gets emailed every week, or something like that, right? You can make something that is a little bit more high impact than a one-off, hey, here's the plot, here's the graph, right? The interesting thing is when we put Plumber in here as a way to transform the work that we've done into API endpoints, we open up this entire new world where we can still service the avenues that we're used to publishing to, so we can still provide access to our work through Shiny. We can still provide access to our work through our Markdown. And that's all well and good. And in fact, if this is all we do, it's a little bit of an awkward paradigm because what I'm doing is I'm writing a bunch of R code to turn what I've done into an API to then call it from a bunch more R code. And that's just kind of like, why the round trip, right? Why not just go straight to here? And that's definitely viable. But the interesting thing is when you look at it in this light, where now all of a sudden, if I've exposed all of my work through these API endpoints, I'm not limited to the R ecosystem anymore. I've opened my work up to be leveraged across my organization, regardless of how people want to receive and ingest what I've done, right? So if I've got something that's written in JavaScript that my front-end developers are working on, they don't know R, and they don't want to go through the hassle of trying to figure out R. And the last thing they want to do is go through and try to figure out what your R code is doing to re-implement it in whatever language they're using, right? Same thing with Go. Substitute any other kind of language or paradigm in here. But the nice thing about all of this is that with HTTP, you don't care. You can communicate, and somebody can write their little script in Go, communicate with R, and they never have to know that R is running in the background, right? They're oblivious. All they're doing is making an HTTP request, which they're well familiar with. And the whole idea is we want to avoid this situation, right? Where I've written a bunch of stuff in R, and then I go to my engineers and I'm like, hey, so I want to use this in production. And they look at it and they're like, what is this, right? That's never a good exchange, because R is a little bit idiosyncratic, right? It's a little bit weird. And especially to people that are used to other languages like Go, Java, Scala, JavaScript, whatever the case is, it's a clunky handoff to say, here's my model, now you do it in your thing, right? And it becomes kind of this awkward exchange. So that's why, again, that's why I feel like this is important. Now, in terms of what Plumber is and how it operates, it's actually pretty brilliant in its simplicity, and that's one of the things that I love about it. There's various other packages and things out there that kind of fill a similar space in terms of providing R as an executable API endpoint. But I think Plumber has kind of hit the nail on the head in terms of approaching this with a really simple interface. And that is, you can turn any kind of R function that you want into a REST API endpoint just with some special comments. So you don't need to relearn some new kind of paradigm of R coding. You don't have to learn some new package that involves a bunch of methods that you just have to wrap your head around. You can take R code that looks and behaves just as normal. You can slap a few extra comments on it, and it becomes an API endpoint. And that's really powerful because there's not a lot of overhead to go from here's all the work that I've done to here's how you can consume the work that I've done in a realistic way. So let's kind of walk through. This isn't a screenshot. I apologize if the contrast is kind of wonky. But let's kind of walk through some of the pieces, and then we'll dive in and look at this specifically with some examples. So the first thing, Plumber's a package. You can just install it as you would any other package with install.packages. It's also on GitHub if you want to install kind of the bleeding edge version from GitHub. So load the package, and then the rest of these comments provide context to Plumber to build your API. So Plumber uses something called Swagger. If you're not familiar with it, that essentially just provides kind of a nice out-of-the-box way for you to interact with and see your API without having to resort to something like curl or a command line utility. And we'll look at what that looks like in a minute. But there's these annotations, so I can label my API. I can add I can add a description to my API. I can add different things like that. And then here's a specific endpoint that I'm going to make a request to. So my first comment here with the hashtag star symbol is describing what this endpoint does. And again, this is all kind of for documentation in Swagger, so that when I run this API, I'll see a little snippet that says, hey, here's what this endpoint does. I can describe my parameters. So in this case, I've defined a function that takes a single parameter message, and I've defined that this message parameter is going to be the message to echo. And we'll see how that looks in just a second. And then here is where I define my HTTP method. So I'm going to use get, and then here's the specific path of the endpoint that I've defined at /echo. And then here's the function that will be executed. So if I make an HTTP request to this echo endpoint, I'll see what will be returned to me is a JSON object that contains the messages followed by whatever message I input to that particular API.
So it uses annotation to allow the server to redirect.
Correct. Yep. So the nice thing is it kind of abstracts away all the nitty-gritty of putting together like your request handlers and everything like that, right? And then when you run this, Plumber takes care of all that plumbing behind the scenes, and you haven't had to do a lot of, again, the idea is there's minimal overhead to go through the process of turning this into an API. I've got my function, I decorate it with some comments, Plumber handles all the underlying architecture and making sure that the server responds and redirects and everything like that.
Can you intercept the request before here?
You can, yeah. So we'll look at that. We'll look at an example of that. You can add filters that do all kinds of things. They can intercept, modify your request, check for authentication, things like that. Yeah. Okay. Oh, and then the last thing, So this other example, this other endpoint down here, same context, same structure. The only thing that's different is it has a separate serializer. In this case, it's serializing the output as a PNG file. And essentially what that does, Plumber has a set of built-in serializers as well as the ability to add your own. And a serializer is simply the way in which you take whatever R object your function returns and transform it into something that can be consumed downstream. Right? So most downstream applications don't want to receive like an R list or a data frame because they don't know what to do with that data structure. But most APIs are comfortable communicating via JSON. And so by default, Plumber will try to turn whatever your function returns into JSON. But for like a graph, that doesn't make a lot of sense, right? So you can actually define and say, hey, there's a PNG that's coming out of this. And what Plumber does behind the scenes when you add this annotation is it says, OK, it takes whatever the output of your function is, it serializes it, it returns the binary file that in the response body of your API so that your downstream consumer can grab whatever content you've created. OK, so that's a lot of chit chat. Let's look at what this actually looks like. So this is kind of the default hello world Plumber example. So in the latest versions of RStudio, there's a new release preparing to come out, version 1.2. You can download the preview version today, or the daily builds have this. And then there's actually some built-in functionality to help with Plumber. So if I go to new file, I can create a new Plumber API. This will bring up and create a new subdirectory where I can create a new API. And when I do that, this is the script that gets created by default for me as a way that I can come in and kind of have a place to start, right? The other nice thing is, and we'll talk about this in a second, I get this nice Run API button that appears in the top right-hand side of my of my editor, so that it's really easy for me once I'm working with my API to run it and test it locally. So again, here's the same thing that we looked at before. I've got my title. I have a few different endpoints. This first one is a endpoint defined at echo. It will respond to GET requests. This one will respond to GET requests at the endpoint plot. And then here I have a POST request that will respond to some. We're not going to dive too much into what the different methods mean, but there's a handful of various methods. Plumber actually supports quite a few HTTP methods, and they're used. The nice thing about them is they're fairly intuitive. GET, I want to get something that you have. POST, I'm sending you something, and then you can do something with it and return the result back to me. There's also put, there's delete, there's different verbs that you can use. So if I run this API, a couple things happen. One is I have this command that gets automatically run in my console, and this is how Plumber builds and runs the APIs that you create. And so I could run this code just without pressing this button, and it would do the same thing and run my API. The other thing is, if I look at my viewer pane, let's zoom to viewer, there we go. No, you don't want to do it. There we go. So if I look at my viewer pane, it's the joy of working with the daily builds. Sometimes things go weird. Here I have that Swagger interface that I was talking about before. And so this is kind of nice because this just comes for free with Plumber. Now I have something that shows me, one, my API is working, which is exciting, right? This is kind of a cool moment. And two, this gives me a really neat way to look at what endpoints I have, and also a way to interact with them. So if I come in here, I have this echo endpoint that we looked at before, and we know that it takes, and so here we can see how some of this magic is happening, right? Here's that annotation that I had that described the endpoint, and so it's put that in here. It tells me that it takes this message parameter, it's a string, it gets appended as part of the query. I can let it know that I'm expecting JSON as a response. Then I have some additional things here. The nice thing is I can click on this try it out button, and now I have the opportunity to come in and say, okay, hi there. And so here I see what the specific request was that was made using curl. And then I see the response that came back from my API. Right. So again, this has been turned into JSON. If we look back at our source code, we'll see that within this function that defines that endpoint, we're actually just returning a list that has one object, this message object, that contains the text that I've built out of the message that I received. But if we look at our response here, we can see that it's been turned into this nice JSON object that could be consumed downstream by somebody, which is kind of cool. So let's look at one other thing. We can look at this plot endpoint because it's just kind of interesting to look at how plots are returned. So now I've executed. So this function, if we come back and look at our source code for a second. Come on. If we look at our plot endpoint. So I have no parameters to this function. This is just returning a histogram of a random normal distribution. And then the only thing that I've done specific to this endpoint is I've said, hey, this isn't JSON. I'm turning this into a PNG. So handle that for me, please. And then when we execute that endpoint, so we make the request. Here's the specific request that was made. I hit this endpoint. I send a GET request to this endpoint. The server responded and said, hey, here's the graph that you requested, right? So kind of nice. Again, kind of this neat way to share and distribute your artwork. Now, let's kind of look at an example that I think that goes a little bit deeper and highlights some of the additional strengths of Plumber, as well as kind of showcases where I feel like Plumber fits within the R universe and kind of the broader data universe in general. And that is, like, I don't imagine a case, and maybe there's one, but I don't imagine a case where somebody's going to go out there and build an entire website using Plumber. It's possible. You could totally do that. But it's definitely probably not the right tool to do something like that, right? It could be a fun proof of concept. It could be a good learning project. But you're not going to build your company's website on Plumber because that is a weird design choice, right? But what you do want to do is you want to let Plumber expose R's strengths to the rest of your organization, right? If I've got a model that I've worked really hard on, or maybe I have this awesome graphic that I can re-render on any given new input of data. And I want a way to embed that in some other application within my company. Or I want a way to share this model or leverage this model in something that my customer service agents are using while they're on the phone or something like that, right? The idea is I don't want to go through the rigmarole of transferring everything to some other language or doing everything in a batch job or something like that. I want to make this available in real time. And Plumber excels at that. And that's where I feel like Plumber's strengths really shine. And so let's look at this example. Let's see. Okay. So this kind of goes on that example of I've created some sort of model and I want to share this with others within my organization, right? So first things first, I have my model. In fact, we can look at this. This is a really fancy model, you guys. There we go. All right. Super intense. So I've created this linear model. I've thrown everything in there, right? Super overfitting to this tiny data set. And then I'm just saving this out. But again, the idea is this could be whatever, right? You've created something really awesome and you've saved the object out. And now in your API, the first thing I do is I load this model. And so what this will do is when Plumber's running and serving these API endpoints, it creates this shared environment where this object will now be available to all downstream endpoints. And that's nice because I don't have to embed this in the endpoint itself where I have the overhead of reading the object in every time somebody makes a request. The object is just available in the R session that's serving incoming requests, right? So anything that you put out here, including loading packages, any data that you have, any functions you define, are available to all downstream Plumber functions and requests when Plumber is serving that particular API, which I think is really nice. So we've got our decorators, we define our API, and now we'll look at a couple of different things that we've got. So this goes back to the question earlier, right? Can I intercept my requests before they reach their endpoint? And I definitely can. I can create what are called filters that do just that, right? They take the incoming request, and then I can do whatever I want. There's kind of three use cases for these filters. One is I can modify the incoming request. So and we'll see an example of that in just a second. The other thing is I can check something and maybe throw an error. For example, if I'm looking for a specific cookie from the user, or if I'm looking for some form of authentication and it's not there, I can use a filter to throw an error before my request reaches an endpoint and perhaps does something I don't want it to do. And then I can also just respond to a request from a filter. So that's kind of a combination of throwing an error, right? Maybe I have a filter that instead of throwing a nasty error, I just want to tell the user, hey, you didn't actually provide me with a valid ID, try again, right? And I could catch that in a filter before I'm running through the endpoint itself. in this case, this filter that I've defined, this actually comes from the Plumber documentation. I just lifted it over because I think it's a nice thing to have, and we'll see it in action in a second. This just kind of logs out some details about each incoming request so that when I'm running this and making requests, I can actually come over to my R session and see printed out in my terminal information about the time of the request, who's making it, what's the method, what path, what's the endpoint that's being used, and where is this request coming from. Question?
Does Plumber have structure built in for sessions for users? And
So you can store and manage cookies through Plumber, and that's the way that you would handle that. Again, the idea being, if you're trying to truly be RESTful, you'll push all of that stuff to the client, right? Everything that, in terms of like managing the state of the client, and cookies would be the way that you would do that. So you can set like regular cookies. You can also set encrypted cookies, and send those and push those back to the client from Plumber. Yep. And the last thing I'll say about this particular filter is, once I'm done, I have to call this forward function. There's kind of a common gotcha with Plumber is forgetting to do this. If you don't do that, your request just kind of dies in this filter, and you're kind of like, what happened? Like, why is it not working? So forward tells Plumber to send the request on, keep it moving down the pipeline. So this is an example.
Is this set up like a middleware script where just every request comes in and then just hits these functions in order?
Yes. So it'll hit your filters in order. You can define specific endpoints to like ignore specific filters. So if you want an endpoint to be served without passing through, one or more filters.
Post request, it'll skip these steps.
Right. Yep. So you can kind of define that pipeline. But with your filters, the default behavior, it'll just kind of step through each of these as part of that pipeline, and then go to the request that it meets. Right. It'll find the endpoint. It'll be routed to the proper endpoint, and then that request will fire. Yep. So here's one more filter. This is an example of editing the or updating or mutating the request itself. And so what we're doing here is we're checking to see if they're calling something on the predict endpoint. And if they are, we're going to actually parse the data that they've submitted, the data that's come in with the request, and append that and add that to our request. And then we're also going to add the predicted values from that incoming data to the request so that we don't have to recompute those down the line, so that we can reuse those values for like a plot if we wanted to, or we could reuse them to just return the actual data to the client, whatever the case is. Now those just belong to the request, and I don't have to worry about recomputing them downstream. We also check to say, okay, well, if you made a post request but you didn't include any data with it, we'll give you a little error that says, hey, you didn't actually attach any data to this request, so I can't actually predict anything because there's nothing to predict on, right? And so that's what this is doing, and setting the status code to 400, letting the user know, hey, made a little bit of a mistake. Here's how you can fix it. And then we have various endpoints. So one of our endpoints is to just return the predicted values. One of our endpoints is to return a table, a little HTML table of the predicted values along with the original data that was submitted, so you can kind of see a nicely formatted table. And then we have an endpoint that produces a plot that we can manipulate and use. So let's run this, and we can kind of see what's going on. So here's my Swagger interface, and I can see the different endpoints that I have defined. The interesting thing here is if I come over and look at my console, I can see that some requests have already been made because Swagger was being generated, and so some requests were being made. And this is that logging filter that's just printing out information to my console as requests are coming in, right? So I can see here's the time of the request, here's the verb that was used, here's the endpoint that was hit, here's the user agent. This big old user agent just saying that this was a web browser making this request, and then some additional details about where this request is being hosted. Right now, this is just running on my local machine, so it's 127, and there's a series of requests that get made to render that Swagger interface. So one of the reasons I wanted to use this particular use case and example is because a common question that I see and that I kind of have with Plumber is, well, if I want to expose models, which I feel like is kind of a natural case for this type of thing, how do I get the data, like the new data, into that model, right? Like, what's the best way to send that data over to the API? Because one thing I could do, and I've seen a few people do this, I could define, if I look at my predict endpoint for a second. Let's see. Right here. So this endpoint right now is just returning the pre-computed predicted values from the request. But one thing I could do is I could write a function here in terms of like every variable in my data, right? So I had like horsepower, and I had displacement, and I don't remember what the other one, weight, I think was one of them. And the nice thing is, then I can just append these to like the query that I'm making to the API, and then I can ingest them, and then I could like build a little data frame in this function, and then predict on that data frame and return my results, right? That's one way to do that, which that works and it makes sense, but it becomes really cumbersome if you've got a model with like a lot of inputs, right? Now all of a sudden you've got a function with like 85 parameters, and you're just cobbling those together into like some sort of data frame on the other side, and that's not super ideal. And so another way to do it is when we make, all these endpoints are defined as post endpoints. Post is nice because I can actually send some data over to the server. And Plumber will get that as part of the request, and then I can kind of do whatever I want. And so if, in this case, I'm expecting some JSON data that defines the new data that I want to predict on. And if I look up in my filter, all I'm doing is I'm saying, OK, well, take the data that's in this, and we'll look at what this request object is in just a second. Take the data that I'm getting, parse it from JSON, and give it to me in a nice little data frame, and then I'll use it down here to predict my new values, right? Here's the data that I've parsed out of my out of the request object, and here's the model that I've loaded at the very beginning of my R session, and do it that way. And I think this actually makes a lot of sense. So let's kind of look at this in action. I actually want to do one thing really quick, and that is, one of the nice things about Plumber is that because it's just running native R code, you also have all your native R debugging tools. And so we're actually going to add a browser statement right here. And what this will do is this means that when this endpoint's hit, my R session will actually like pause for a second and drop me into my environment as it is right here. And I want to do this so that when we make a request, we can get in there and kind of look around at what the request looks like and get an idea of like how Plumber is handling the incoming request and the outgoing response. So let's run this. OK, one last caveat, and then we'll look at it. It's kind of tricky to handle like submitting data in a post request through Swagger, at least in the way that Plumber exposes Swagger annotations. And so I'm actually going to use a utility called Postman. That's a nice little GUI for interacting with APIs. It's actually really cool. You should check it out if APIs are interesting to you and you find yourself working with them a lot. But it gives you a way to define requests and handle the data that's being sent in the request and things like that. So here is, that's really tiny. Let's see. No, that's OK. So here's that endpoint that we had, that predict endpoint. So the idea is I want to submit some data, and all I want to get back are the values, the predicted outcomes from my model. And so I have this JSON data right here that I can attach to my request and send over to the server that's running Plumber. And so if we hit this request, notice this is just now waiting for a response because my R session is paused, right? Because I inserted this browser statement. And the nice thing now is we can come in here and we can kind of look at what we have. So the request object is actually an environment. Let's see. Let's zoom into this. OK. So here's all of the objects that exist in my request environment. And this is how Plumber handles incoming requests. It creates this request environment. That environment is passed from filter to filter to filter until it reaches the endpoint that it was routed to, right? And so that's one of the nice things about that is if we remember back to the filter that I defined, I just modified this request object. I didn't have to then like specifically call that object later on in my endpoint. That request object is just automatically passed with any mutations that have happened to it, so that when it gets to my endpoint, which I'm at now, I can see that I have this predict data value and predicted values that are part of this environment that now have that data frame. In fact, if I look at request, if I look at this, this is the data that was submitted from the request. If I come back over here, just kind of for context, here's the JSON that I submitted into this request. So that first car name, Mazda RX-4. If I come over here, Mazda RX-4. So this has all been parsed from that JSON request, and now it's available to me as this data frame within my object, right? if we look at the raw data, and that's available in this post body object in this environment. So if I look at, here's the actual JSON that was submitted that I then parsed into the object that I used. Right? So if I hit continue here, it runs through the rest of the function. There was no other browser statement. So if I come back over to Postman, now I have returned this JSON object that contains all of the predicted values that I used. Right? Now let's look at one other endpoint. This is one that we haven't gone through in terms of the definition within R, but we'll look at that in just a second. But this is kind of the same idea. I'm sending the data over in my request. I'm calling predict table, and then here's kind of the fun thing about this endpoint is I have this final part of my path that I can add any specific variable. I can attach any specific variable that's in my data there, and it will highlight that column in the resulting table. So let's leave it at HP. Take a look at this. So what's happening with this request is now I'm actually returning an entire HTML table that was created in R. And kind of the fun thing is the path that I'm requesting this table on is determines the actual table that's returned. So in this case, notice the HP is highlighted. If I change this to, let's say, weight. Now I have a new table, and the weight column is highlighted, right? And let's look at how that's happening on the R side really quick. So here's that function. And here's kind of the other nice thing, or one of the other nice things about Plumber, is that I have two ways that I can define parameters. One, I can just define them as something that's passed into my function and is available in, like we saw in that Swagger UI. And when that happens, it's appended as a query parameter to my request. Now, in this case, what I've done is I've defined a parameter within the path itself. And this is a really nice utility and kind of conforms to modern API thinking where, for example, if I'm thinking about like a user database, right, and I have a bunch of user IDs, I have thousands of users, and I want their details to be available at like user/user ID. I don't want to have to create like a separate endpoint for every user because one, that's a lot to maintain, and it's just a lot of headache, right? Instead, I can add a parameter in my path, and now this parameter becomes available in my function. And so that's why when we changed, if we come back over to our request, when we changed this from HP to WT, it grabbed that part of the path and said, oh, I'm passing this into the function. This is the column you want me to highlight, right? If we change this to something else, DRIT, run this, right? Now we have this column that's highlighted. Okay. Now I'm kind of running short on time, but I want to highlight one other thing and then open up for any. If we put an invalid one, great question. Let's do that. Let's do drats So nothing happens, but I have a bad request, right? And I have actually handled that. That's a great question. If we come back over here, that's handled right here, right? So if the column doesn't exist in my data, set the status to 400 and then just return an empty value, right? And so the downstream user would say, hey, I noticed that it's a 400 bad request. Now I could include some text in here. Kind of the interesting thing is, and I'm still kind of trying to work around this because I know there's a way to do it, I just haven't figured it out yet, is because I've said that this is serialized as HTML, if I return just some text here, it like throws the whole thing off, and it ends up throwing a 500 error. So I know there's a way to do it, I just haven't figured it out yet. So right now it's just returning a 400 error without any additional detail to the user. But ideally I'd say like, hey, that column doesn't exist, and that's why you got this error. Okay. So one other thing that I want to highlight really briefly, is kind of the idea of deploying these things. So this is all just running on my laptop. That's all well and good, but I don't want my laptop responsible for hosting the API my company is relying on because that seems like a terrible idea. And so there's a couple of different things you can do. One is you can use RStudio Konnekt, which is one of RStudio's newer professional products that provides a publication platform for things created in R. And it's really nice because it just recently, within the past 6 months or so, has added support for Plumber. And that's what this little blue button is right up here. So I'm in a Plumber API. I can come in here. I can click on this button. It opens up this interface. It says, hey, I've actually already published this, so let's actually publish a new version of this. Let's come in here, other destination. So I come in here, I can click publish. What it's doing right now, the nice thing about RStudio Konnekt is it handles all of my package dependencies. So it's making sure that I have everything available in terms of like the right packages, the right environment on the server. And then if I come and look at, let's see. Come on, where are you? Did I lose my? I think I lost my Chrome session that was open. Okay. The idea is this will pull up automatically and you'll be able to interact with your API via your browser. The other thing too, and this is, you can kind of read more detail about this in the Plumber documentation, but Jeff has done a really good job of like making it really easy to publish these things. So RStudio Konnekt is one application, but if you're not a subscriber to Konnekt, you're not part of a company that has a subscription to Konnekt, you can actually publish to DigitalOcean like really easily, and it's really it's a really nice kind of route to go. And so this script, and this is in the repository for this talk, this script goes through that process of just from within R, I can define my API, and then I can come over here, I can run this script, it'll go out, create a new server for me in DigitalOcean. I'll install a couple of the packages that I'm dependent on, and then I'll publish my API over there, and I have a running API that's available. And it does some really nice things also behind the scenes. It installs Nginx on the server to handle some of the routing. It installs a firewall on the server to protect access to that server. And so there's some nice things you get for free with doing this particular implementation. But then again, the documentation for Plumber goes through like various ways in which you can publish and deploy this. Which one? The Analog C, DigitalOcean? Yeah. It's one of the more clever package names out there, I think. Great. So let's see if I can find where my slides disappeared to. There we go. Okay. Okay, so just kind of a final thought, and then I'll close. The idea is it's very easy and approachable in my mind to take all the work that I've done in R, all this hard work that I've done, and expose it and publish it in a way that's immediately consumable by others within my organization. And that, again, is a game changer because historically I've been in positions where I either go through this process of, okay, well, I have this thing, but now I've got to set up some sort of like batch process thing that runs every night at 2 o'clock in the morning and sends me an email if it fails, so then the first thing in the morning I can fix it, right? Or I've got to like go to the engineers and say, hey, can you rewrite this in Scala? And they roll their eyes and they say, well, that'll be like 8 months. And I'm like, well, by that point this will be obsolete, so never mind. And it's not very efficient, right? And I feel like I get in this position where I feel like, okay, well, I've done all this work, but now there's no way for it to really like make the impact that I feel like it could be making. Whereas now, I've done all this work, I can make a couple of API endpoints, I can publish those, and immediately it can be used in X, Y, or Z system within my company, which I think is really powerful. And so in conclusion, here's some additional resources. I'll make sure that I post in the meetup comments where the repo is for this talk. The slides are on there. All of the code that we've gone through is on there. Great. We're wrapping up right now. So that is what I've got. Thank you.
Awesome. Thank you so much, James.
Yeah.
That was fabulous and super helpful. As someone who has done a little bit with this, and then that adds a lot more to that. So how about if we wrap this up and unpack, and then if we've got questions, maybe we can ask them right out there.